Math!
Unit 4, Lesson 8, 8.2. So we're working with interest and depreciation. So number 1, we have money in a particular savings account increases by about 6% after 1 year. So how much money would be in the account after 1 year if the initial amount was $100? What if it was $50? What if it was $200, $125, or any amount of dollars? How could we figure out the amount of money in the savings account? So an increase of 6% tells me that I actually will have what percent of my original amount? 106%. So if I already had 100 and I'm adding 6%, be 106%. So then to determine the amount of money after 1 year, I would find 106% of 100. So if you remember, one way I said you could do that was to change a percent to a decimal. And to do that, we just move our decimal place 2 places to the left. So 106% is the same thing as 1.06. So then we would just multiply. So if I had $100 and I'm increasing it by 6%, which is 106%, then I would just multiply times 1.06, which would give me $106. So if I initially have $100, after 1 year, my savings account would have $106 in it. Okay, what about $50? Same thing. So it'd be 50 times 1.06. Okay, $53. Okay, what about $200? Be 200 times 1.06, which would give me $212. Okay, what about 125? So it'd be 125 times 1.06, which would give me $132.50. Okay, so what about for X amount of dollars? Okay, so for any amount of dollars, how would I determine the amount of money after 1 year? Okay, so it'd be the same thing. My amount of dollars times 1.06 would tell me for X dollars. So one way to simplify that would just be 1.06 times X. Okay, number 2, the value of a new car decreases by about 15% the first year. So we have a decrease of 15% in the first year. So how much would a car be worth after 1 year if it was originally worth $1,000? We know it's decreasing by 15%, which means it's worth what percentage of value? So it's originally worth 100%. We lose 15%, so that leaves us with 85%. And then you can just change that to a decimal. So 85% would be what decimal? 0.85. So if it was originally worth $1,000, it would now be worth what amount? So 1,000 times 0.85, $850. Alright, what about $5,000? Same thing, 5,000 times 0.85, which would give you $4,250. Okay, what about $5,020? 5,020 times 0.85, which would give me $4,267. Okay, and then we have for X dollars amount. So it'd be our dollars times our decimal, which would simplify as 0.85 times x. 8.3 says match an equation to each of these situations and be prepared to share your reasoning. So number 1 says the water level in a reservoir is now 52 meters. If this was a 23% increase, what was the initial depth? So how would we determine the initial depth? So we know a 23% increase means that I'm working with my 123% is equal to 52 meters. So therefore, if I change my 123% to a decimal, it would be 1.23. And I know I could multiply that times my original amount, and that would have to give me 52 meters. So here would be my answer for number 1. Okay, number 2, the snow is now 52 inches deep. If this was a 77% decrease, what was the initial depth? Okay, so a 77% decrease means that I only have 23%. So now 52 represents 23% of the original amount. So I change it to a decimal, 0.23 times my original amount. And that would have to give me 52. I just noticed I put 53 there. Sorry. Okay. So for number 2, we have our first equation. Okay, 8.4, it says the gas tank in Dad's car holds 12 gallons. Mom's truck holds 50% more than that. So how much gas does the truck's tank hold? So we've worked this problem before, but it wants us to explain why this situation can be represented by the equation 1.5 times 12 equals T. So first, what would T represent? Okay, so T would represent the gallons in Mom's truck. First, I know that the 12 represents my 12 gallons. What does the 1.5 represent? That would represent my 50% more. And it's important to include this more, because 50% more means I have my original 100% of 12 plus an additional 50%, which gives me 150%, which is 1.5 as a decimal. Okay, so 1.5 times 12 would tell me what 150% of 12 is. Number 2, it says write an equation to represent each of the following situations. So a movie theater decreased the size of its popcorn bags by 20%. The old bags held 15 cups of popcorn. So how much do the new bags hold? So if it decreased by 20%, that means it actually holds 80%. So if I change that to a decimal, it'd be 0.8. Okay, and I know the original amount is 15 cups. So it'd be 0.8 times 15, and that would give me my new bags. So I'm going to say my new bags is represented by N. So 0.8 times 15 equals N. B, after a 25% discount, so here's our discount, the price of a t-shirt was $12. This is after the discount. So this is actually my new amount, not my original amount. So the price before the discount, this is my original amount. And I'm going to represent that by, let's just say, we can do P for price. So the price before. So what would be my equation here? If I had a 25% discount, I paid what percentage? 75%. Okay. And I had to multiply my percentage times my original amount. But do I know my original amount? No, I did not. So 0.75 times P must equal 12. Okay, C, compared to last year, the population of Boomtown increased by 25%. The population is now 6,600. So is this my original amount or my new amount? This is my new amount. And we're looking for last year's population, which would be my original amount. And we can just use P again for people. So compared to last year, we increased by 25%, which means we have what percentage? 125%, which as a decimal would be 1.25. And we always multiply our percentage times the original amount, which is P, because we don't know what the original amount was. And that gives me my new population, which is 6,600. Okay, so you can use equations to express percent increase and percent decrease. For example, if y is 15% more than x, then we can represent it using any of these three equations. So these three equations all represent the same thing. So when you have just a variable, you should know that there is always an invisible 1 in front of that. So 1x plus 0.15x would give you 1.15x. Same thing here. 1 plus 0.15 is 1.15x. So these are both correct ways to write it. This is just our simplest form. And then here you can see, instead of writing y, they wrote 1.15x because that is what y equals. Okay, so if someone makes an investment of X amount of dollars and its value increased by 15% to 1,250, then 1,250 would be your Y amount. So 1,250 is equal to 1.15x. And that would tell us the amount of the initial investment. Okay, if A is 7% less than B, so we know it's 0.7% less than B, and you notice that's not shaded in. So we have to subtract that from the original amount of B. And again, we have our invisible 1 here. So 1B minus 0.07B gives us 0.93 times B. Same thing here. Remember your distributive property. So you have to multiply this times both of the inside of the parentheses, which would give you 1B minus 0.7B. I just want to go over a couple more problems. So this is not one of your assignments. I just want to work through a couple more problems so that you feel more comfortable. So we have a pair of designer sneakers that was purchased for $120. Since they were purchased, their prices increased by 15%. So what is the new price of these sneakers? How much would somebody have to pay now if they went and bought them? Okay, so we have an increase of 15%. So we know 120 is our 100%. And then we get an increase by 15%. So before, I've always had you combine it to 115%. But I want to show you a way you can do it kind of mentally in your head without having to always work things out. So to find 10% of any number, you move your decimal one place to the left. So that means 10% of $120 would be what? One place, $12. So 10% is $12. Well, if I know 10%, then I should know what 5% is. Because 5% is half of 10%, so 5% of 120 is $6. Okay, so I know that 15%, if I add these, 15% of 120 is $18. So I know they increased by $18. And if they were originally $120, I had an increase of $18. These sneakers now cost $138. Okay, so then if you use the 115%, then you would just do 1.15 times 120, which would also give you $138. So both methods work, but if you're doing it mentally in your head, you can just find the 10% and work from there. Okay, let's look at number 2. Elena's aunt bought her a $150 savings bond when she was born. When Elena is 20 years old, the bond will have earned 105% in interest. So when Elena turns 20, how much will her bond be worth? So she's now earned 105% in interest. Interest is an increase. So 105% increase is what total percentage? Have to add 100% to that. So now she has 205% of her original amount. So then you could just multiply, or you could do the method up here. So I could multiply, so 2.05 times 150, or I could break it down to figure out 10% of 150. Well, I know that would be 15, but I need 5%. So 5% is half of this, so $7.50. And I know 100% is $150. And then I have my original amount. So this right here is my 105%. So 105% is $157.50. But then we know she started out with $150 as well. So we'd have to add that, which would give us $307.50. So it looks like more work to use this method, but it's really not, because you can do that in your head and not have to use a calculator or work the problems out. Once you get good at percentages, this way will be a lot easier. So if we had used our original method here, 2.05 times 150, we also would have gotten $307.50. Alright, number 3. Move that out of our way. In a video game, Claire scored 50% more points than Tyler. C represents the number of points that Claire scored, and T represents the points that Tyler scored. So which equations would be correct? So we know Claire scored 50% more, which would be Tyler's amount plus 50% of Tyler's amount. And that would tell me how much Claire scored. Well, to simplify that, I can't multiply a percentage. I have to change it to a decimal. So that leaves me with T plus 0.5 T equals C. Well, there's one of my equations, T plus 0.5 T. So I know C is correct. Okay, what else would be correct? What about B? No, because it's missing the T here. So B is not correct. Same thing on D, adding 50 points. It didn't say 50 more points. It said 50% more points. So I know D is also not an option. Okay, so remember I said there's always a 1 in front of a variable that doesn't have a number. So 1T plus 0.5T. 1 plus 0.5 is 1.05 T. So A would also work. 1.5. And then this is also the same thing. So 1 plus 0.5 times T. Well, 1 plus 0.5 is 1.5 times T. So E would also be correct. So we have A, C, and E. Okay, so now you will work on your Khan Academy assignment.